Okay, so it's very nice to be here, and today I'll be talking about privacy in data management. So I understand this is a security conference, but the talk is a little bit different, so it's more focused on the privacy, and in particular the data-centric, so databases and how to share data and things like that, not privacy like Tor and anonymous communication from that aspect. So we basically have a lot of data. We have sensors data, we have healthcare data, we have Facebook, Twitter, email, RFID, and lots of data. And there are a number of reasons for this data revolution. We have bigger computers these days. We have small sensors that collect data about us, around us all the time. We have bigger storage and more bandwidth, so we can now integrate data. We can analyze them. We can ask a lot of questions. So these things, all these things, we call it big data nowadays, right? So big data, what can we do with this? Big data can help us to basically help us to answer a lot of questions. Questions like, for example, which treatment is the best one? Is one drug is better than the other one? Can we detect the onset of a disease earlier? Or for example, in the case of communication, where people live, where they work, how they communicate, can we better manage the infrastructure? How to manage the traffic better with the existing infrastructure, for example. Social network questions like how do people interact with each other, right? So all these questions are great, and we would like to know them, and data is definitely the power, but there is a but here, right? And what is that? The problem is the data and the privacy. So all these data, any organization who is collecting data is our data, right? And any organization that collects and shares this data must take proper measure to make sure that this data doesn't leak out in a way that it compromises our privacy, right? And if you look at how the current system works, is basically these two things. Basically, you need a data set. For example, researchers need a data set from a hospital to do cancer research or whatever. You have to first submit an application. It will go through the ethical board. You wait for a long time. You sign a legal contract, and so on and so forth, right? Our take is that, in one hand, here there are two cases here. One is you have a lot of data, big data, and you don't want to do a lot of research. But at the end of the day, this also hampers privacy. And if we do not do this balance properly, then it can have two things can happen. One is big data research can kill privacy, or because of the privacy reason, we may not do big data research. You see what I'm saying? So you either don't do any more big data research because that hampers privacy, or you go on and then you hamper privacy. So how to get it right? And I think that if we get this problem done, then it will also facilitate big data research, because we're not going to wait for a long time. There are people waiting for a long time, and sometimes they don't get data for doing research, So what we do normally, so this is the current practice. So let's say you have it's very easy to give you an example with a hospital scenario. It's easy. So let's say a hospital has a data set, right? So these are all patients, let's say, Bob, Gary, and so on and so forth. So each record is a patient. And now somebody showed up and would like to get a data set for example, want to do a classification analysis, would like to know, given the history, is that patient is more likely to develop a cancer or not, for example, okay? So the normal practice is that chop out all the identifying attributes, the attributes that reveals your information, right, directly. Can identify you. For example, in this case, name, or phone number, or email address, or exact address, for example. So if you remove them, it looks good, right? So now we can give it. What do you think? We can give this data? Sure? Yeah, the data look anonymous. So basically that's the practice currently. But the problem is that, even these attributes that you see, job, sex, age, and so on and so forth, even any particular it's not giving any information, but when you put them together, it reveals an identity. How? Around 2000, in the United States, in Massachusetts, I think, an insurance company was gathering the state employees, all the records, because, the insurance company knows what are the diseases and when you claim for the bill. And they are doing just exactly this thing. They were removing all the identifying information like SIN number and all this name and etc. And then selling it to the other companies, giving it for research and etc. And one researcher, privacy researcher named Latanya Sweeney, she realized that you can buy in the United States the voter list. You know the voter list, right? And it's only cost her, I think, $20 in that time. And then in the voter list, you also have name, you also have job, sex, and age. Now, if you join them together, here you have no name, no nothing. Lawyer, male, age 38 doesn't mean anything to you. But in the voter list, you also have lawyer, male, and also you have all the other things, where you live, who are you, and etc. So in that time, she was able to pinpoint the disease of the governor of that time, for example. Okay? So even if it looks very nice, but actually the data is not anonymous. Because these are, we call them quasi-identifier, means that when you put them together, it makes the individual unique. Okay? So the take is that even if removing only the identifiers to share data, this sort of pseudo-anonymous data is really not anonymous. We need to do much more. So what we can do? Okay, so before what we can do, let's give you some other example, just to make this point clear, that just removing identifying attribute is not enough. In a different setting, in 2006, AOL, American Online, they had the search queries of their client. For some reason, which I do not know, they decided to release some search queries of their customers. So what they did, they chopped out the identifying attributes, meaning that they are not going to tell you from which IP these searches are coming. They're replaced by a random number, pseudo-random number, and then they release that, maybe for some data mining purposes. And 2 days later, some journalists from the New York Times, they found out an individual. So let's do the experiment here together. These are the search of an individual. What do you think? What is the age of that person, you think? 60, great. It's a male or a female? Female? Okay, so you're getting it, right? Okay, so where she lives, you think? Wilbur. Yeah, and what's her family name, you think? You're getting it right. Sorry? Arnold, yeah. I mean, there are guesses. You can do them, trial and error, and you'll get it right? So yeah, so that's it. So when you go to that place, there is a lady, the family name will tell you much more, and then there is only 160 years old female. So that's the lady. And then they knocked in the door, and then, these are your searches. She said, yeah, these are, nobody should know. I mean, she was embarrassed, okay? And then, CTO resigned, 2 employees fired, there is a lawsuit pending, and then they became one of the dumbest moment in the business, okay? So you don't want to mess up like that. So removing, again, the identifying attributes is not enough to share data. You do not share data like that. There are other scenarios. For example, the Netflix challenge. Do you remember? Do you know that, any of you? Yeah. Okay, Netflix, they release the movie names. So they remove the client's information, name, address, or whatever, and they said, okay, client number 1 saw these movies, for example, okay, and they would like to they're releasing this data to build a recommendation system. So they throw a challenge that, okay, build us a recommendation system. If I saw these movies, which one I should see, right? So they wanted people to build a recommendation system, and to give some data, they gave a sort of data, and some of the individuals who are identified. So that's very embarrassing which movies I saw. I don't want to tell anyone. Okay, so to give you the whole scenario, if I abstract it, there are 3 parties basically. One is the individuals. You have the data owner, data publisher, and the recipient. Let's take a hospital scenario. These are the patient. You have the hospital who get the data, and they would like to give it to the researchers, for example, for cancer studies or whatever study you want to do. These are the client. Netflix get all the movie renting, all the movies you saw, watched, and then maybe want to give it to the recipient to build a recommendation system. Maybe you are a grocery store. You would like to know whether your client is buying milk and egg all the time, and should I put them together in the same shelf? Again, the same problem. So whatever organization you take, it's a big data time. So there are clients, and then you have a data owner, And these data owners would like to, maybe the advertisement purposes, maybe other purposes, would like to share this data with advertisers, third-party researchers, et cetera, okay? So the question is, how do we anonymize the raw data so that these bad guys, good guys, do not re-identify an individual, okay? The problem is clear? So that's the problem, okay? And I already told you that just removing the identifier doesn't work at all. I gave you 2-3 examples already. So what we can do? Oh, yeah. So, so basically, we have to fix that 3 things. So first, we have to decide what is privacy, right? Because we would like to preserve the privacy of the raw data. So we need to have some kind of model to make sure that we really preserve the privacy well. The second thing is anonymization algorithm. So we have a privacy, we settle down with the privacy, we say this is privacy, we want to make sure I have a raw data, then I need an anonymizer. So this is more of an algorithm. And of course, these guys would like to do something. So of course, you can say that I will destroy the data. Then it doesn't make any sense because he will not be able to use anything. So you have to also make sure that you want to do a cancer study. So you have to preserve information. So taking these 3 things, so it's an optimization problem in one way. I have to preserve the privacy, I have some utility for the recipient, and I also have to have a clever anonymization algorithm that will somehow balance both the sides. So with that, let's go further. So there are a number of privacy models, and it's just, I'm taking this opportunity to let you know, so this is not my work or something, these are already in the literature, so it's a good survey for this new audience, I think, for security community. So I'll start with the K anonymity, it's an L diversity, T closeness, and if the time permits, I'll go to differential privacy. These 3 are kind of like a same sword, you'll see, and it's a bit different kind. So this is a more like a trendy thing currently. Let's start with the K anonymity. So I showed you that example in the beginning that just removing the name doesn't work, remember? So job, sex, age. And I could basically find out, link an individual with the help of an external information, that is the voter list in that case. So what I can do? The idea is very simple. Rather than just releasing this raw table, why don't we just generalize a bit? What I mean by generalize? Meaning that, oh, rather than saying age 36, why don't I say that age is between 36 to 40, right? Still true, but I'm giving it less information. Rather than saying he's an engineer or lawyer, let's generalize it to professional, right? Rather than, oh, yeah, here I can't do that much. I can just say that, no, if I don't want to release the male or female, I can just chop that column out. The point is that now, if you look at the table here, these 3 records are completely similar, right? And these 4 records, the green ones, are all similar because I generalize the information. So still, each and individual record are true, but I'm giving the recipient less information. Now, if you use the voter list technique, the one I showed you before, you will not be able to pinpoint a particular record anymore, right? So sort of privacy is there at the cost of some utility because I'm giving you less information. So that's the first idea. It's called K anonymity. The idea is you want to make them a group, and each group should contain K records, okay? K similar records. That will make you K anonymous. So if you're 5 anonymous, that means you're gonna have to make sure the table you give out, every 5 records are similar, sort of, okay? You will not be able to pinpoint more than narrow. You cannot narrow it down less than 5 records. Okay, so that will give you some privacy. Any questions? No, okay. So is it good? Are we happy? We use this technique? Yeah? No problem? There are problems. Otherwise, we will be out of job. Okay, there are problems. So what is the problem here? Okay, K anonymity is nice, very simple idea. But you see there are 2 problems. So let me show you the first problem. The first problem is a homogeneity attack. What is a homogeneity attack? Let's say I know a Bob whose zip code is something like that, his age this, and I got at this table. From the table, I realized that he's in the first 3, one of the 3 guys, right? Because I don't know which one is this. Now, because it's a K anonymous table, I know only it's in this group. But look, what is the problem here? It's a homogeneity attack. What does it mean? Everybody has heart disease. I don't care. Whoever he is, he got a heart disease, right? I got it. So if your algorithm is like that it spits out information like this, all the records within a group has the same disease or sensitive attribute, then it doesn't work. The second problem is background knowledge attack. Background knowledge attack is a little bit more specialized. The way it works is that let's say I have a neighbor Carl, and I realize that he is one of the three here, okay? I don't know which one, but one of the three. And I know that from his background that his family doesn't have any heart disease, he will eat well and whatever, from some part of the world who doesn't have any heart disease. So he cannot have heart disease. So he must have cancer. Make sense? So if you have a little bit of background information about your victim, the one you want to identify, then it doesn't work. It simply doesn't work, anonymous table. So, okay, so that's the problem. We are not happy. So what do we do? So the next idea is L diversity. Let me check my time. Yeah. So L diversity. So L diversity idea is very, very, very simple. What is the idea here? Idea is when I break down the table into a couple of groups, within each group I have to make sure there are diverse values. Remember here? All are heart disease and only 2 and I know one of them, right? So rather than doing that, if I can make sure there are L different values here within each group, then hopefully the attacker will not be able to pinpoint or know the sensitive attribute of my victim. Make sense? That's the L diversity idea. Very, very simple idea. Any questions? No. Okay, let's move ahead. Any problem with L diversity then? Happy? Let's finish the work. Talk and L diversity. Let's go on. No, there are still problems. We're not happy. What is the problem here? Let's see what is the problem here. If I give you this data set, what is the problem here? Let's show you a problem. We always find problems, right? We like to find problems. So similarity attack. Look, these 3 values are different, right? So I have a Bob. He is this. I realize that he's one of them here. And these values are now different. So what is the problem now here? Yeah, okay, so his salary, I know he doesn't earn that much. And second is he has a stomach-related disease, okay? So even your values are diverse. If you don't take into consideration what sort of values they're putting together, then it doesn't work very well because it's revealing that his salary is maximum 40K. I would be happy to have a couple of these figures inside so that you really do not know what is his salary, and you know that he has a stomach-related disease. All of them are stomach-related disease, okay? So that's the problem of L diversity. And there are other problems. If you see it, L diversity means that you have to, in each group, you have to have L diverse values. So let's say 2 diversity. What does 2 diversity mean? In each group, I should have at least 2 different values, sensitive values, right? So now let's think about a table where you have HIV patients, for example, and of course there is only 1% of the population, let's say HIV positive, and the 99% is negative, for example. And if you think about that, if I give you 2 classes, in one class there 49 people are HIV positive and 1 negative, let's say. I mean, he doesn't have, and the other 49 people do. And the other one, only one individual has HIV and 49 don't, okay? From the point of view of the L diversity, they are all fine because what is my principle? My principle is that in every class, I should have 2 different values, and that they have 2 different values, but of course you can see this table is very sensitive. The fact that if any individual, if I can link it to this class, equivalent class, then he is very highly likely that he has an HIV because out of 49 records I have HIV, right? You see the problem? So L diversity doesn't understand or doesn't take into consideration these things. A simple definition of L diversity, just for the record, there are different versions of L diversity. I'm just presenting the simplest one. Okay, so that's brings us to the next idea. It's called T-closeness. What is the idea of T-closeness? T-closeness is, okay, the distributions are good, but we need to make sure in every equivalent group, the distribution should be as close possible to the distribution of the overall table. Okay? So it shouldn't be like all heart diseases or all stomach-related diseases, or there is a concentration of one kind of disease as a lot. No, what we have to do, we have to make sure that within each group, the distribution of the sensitive values should be close to the overall distribution of the table. It's a very good idea. 5 minutes, okay. So that's the T-closeness, okay? Is it good now then? Are we happy?
No, but I don't know why.
Sorry? Sorry? Okay. Okay, so let's see this table. This is a perfectly good table. It is 4 anonymous. That means in every group there are 4 values. It is 3 diverse, let's say, because you have 3 different values in every group. And it's a perfectly T-closed. Overall distribution is same to in every group. The distribution is same. So do you think if I get a table like that, steal and privacy attack is possible? Is there any linkage possible? Can I find out an individual? Of course do. I can. How? Given the fact that I have a little bit more background information. So let's say I have a coworker, again, Bob, and he has a disease, and let's say he looks Asian, okay? So if you see this table, you will find out that this is the only record that matches that information. So now you can understand what is the problem. The problem is I have quite a bit of information about Bob. This is first problem, right? I know that Bob already is exposed to this disease. I know that he is an Asian background. So this is one problem. And the second, if you remember that when we anonymized this table, we had two different kinds of attributes. One is quasi-identifier, that we believe that these information I can get from outside, like from voter list. And we considered that these are sensitive information that an outsider may not know. Okay? But the fact that as a coworker, I know that he has a shingles, that's the problem. That was out of my assumption. My assumption is only this information is out there from a voter list. These are sensitive attributes. These are the things I'm trying to protect, and an adversary doesn't know. But no, I do know, and by knowing this additional information, I'm able to identify his record and find out that he has HIV, for example, just making an example, right? So I couldn't model the background information well, right? I couldn't model the background information well. So that leads to, since I have only 4 more minutes, and there are tons of other privacy models which I don't have the time to cover, right? So people are very innovative, right? We tried many different things, but doesn't work anything. So, and there are a number of generic attacks that I have no time to cover, but I just want to give you in the last 3-4 minutes a taste of what is called differential privacy, okay? So it's a very neat idea, and it's you need to know that. So what is differential privacy? I'll skip those slides, okay? These are nice slides, but let's not talk about it today. Okay, so differential privacy is a very different idea. So what I just told you, you need to forget my 26 minutes to understand this, all right? And it's a good there's a security community, so you know a little bit about encryption. So just flash them all the things I talked about. So it's very different from all the other reasonings. In security, an encryption system is secure that if you give me an encrypted value, right? And if you give me a random value, I have no way to distinguish, okay? Because the encrypted value is so random. I mean, I do not know. So if you give me one random value and one encrypted value, I do not know which one is encrypted and which was just picked up randomly, okay? It doesn't give any information, okay? So idea is very similar to that. What is the idea? Let's say I have a raw database, and I have an anonymization algorithm. Let's call it sanitization algorithm. These are the similar words, okay? And my algorithm is going to give an output. And what is the output? I don't care. Let's say any output, okay? I'm giving a table, I'm anonymizing, I'm generalizing, whatever it does. And then as an adversary, if just given the output, I do not know what does the original table look like. Is it this table or that table? And what is these two tables? The only difference from this table to this table is here my record is included. My record means any individual's record is included, okay? And in this table, my record is not included, okay? But this anonymization algorithm is such that if you give me the output, I'm not able to reason whether the original table was this one or that one. And if I'm not able to distinguish that fact, then maybe it's coming from that table. And if it is coming from that table, then there is no way you can make any inference about me because my data is not included in the first place. Do you understand what I'm trying to say? This algorithm has to be such that my data, even if you take out my data, it will give you similar outputs, meaning that the anonymization algorithm will be insensitive to any particular record. So there will be no residue remaining in the version you will get. Okay? So that's the very overall idea. And it turns out that you can only output some particular types of things. How many? 1 minute? Okay. So yeah, it's a very nice idea. I wish I had more time. So let's go to the So conclusion is privacy is a very important thing. We shouldn't take it normally. And we did a lot of things, a lot of good things, but we need to do much more. What we need to much more because there are much interesting applications are coming. Let's say healthcare, the smartphones contains a lot of sensors and they want to track how we run and all these kinds of things, right? Healthcare monitoring applications, social networking, location privacy, cell phone. So all these different ideas are coming. These privacy models doesn't set up good with all the application scenario. So we need to study each of these scenario and need to think about. So we have to design the application from the very beginning, keeping privacy in mind. Okay. So I think that's how I will end. I wish I had more time, but that's it.